How's it going, everybody? Alright, so what we're going to go ahead and do is we're going to be using three variable substitution, okay, with this system of equations. Now, the first step in using substitution is we have to isolate a variable, okay? Now, what I always like to recommend using is using one of these three variable ones, okay, using one of these guys, okay? I tend to go ahead and stay away from the ones that only have two variables in it. Reason being is because I want to use them for later, okay? And what I like to go ahead and do is you'll notice here that in this two variable one, okay, I have myself a y and a z, okay? You'll notice x is not in this. So what I like to go ahead and do is say, all right, I see a y and a z in that two variable. That means I'm going to choose out of the two red ones, I'm going to solve for x, okay? That's going to definitely play into later, okay, and you'll be able to see that. So with that being said, which one appears to be nicer when solving for x? Well, in my opinion, I truly think the bottom one would be easier, because if I take it, okay, what I can go ahead and do is I can subtract 3y and subtract 2z, okay, to both sides. And then I get x by itself immediately, okay? And that's actually very helpful. So let's go ahead and do that. Okay, so boom, we got that ready to go, and that's good. And I'll go ahead and highlight that in yellow because we will definitely come back to him, okay? We will definitely come back to him. Now, when using substitution, you got to isolate the variable, but then you have to go ahead and plug him into the other equations, okay? Starting with the first one, okay? Then, of course, we'll try to plug it into the second one, okay? Now, let's go ahead and plug it into the first one. So I've got 2 times, now what I'm going to do is I'm going to plug in that yellow piece. I have my minus 21 minus 3y minus 2z, okay? And then I'm going to add the rest. So I have minus 2y plus z is equal to 3. There we go. So now when you plug it in, typically what you have to go ahead and do is you have to distribute. What that means is this number, okay, right over here on the outside, I have to go ahead and distribute him to each one of these numbers, okay? So 2 times negative 21 is a minus 42, okay? 2 times a minus 3 is going to be a negative 6y. 2 times negative 2 is going to be a minus 4z. And then we have minus 2y plus z is equal to 3. All right. Now, this problem looks pretty big right now. It looks pretty massive, but we're going to condense them down because we've got some like terms. Notice here I've got y, a minus 6y, and a minus 2y. I can combine that, okay? And when you subtract them, you should end up with minus 8y. Now, you'll notice we also have some z's we can combine. I have a minus 4z and a plus z. That can give me a minus 3z. And then I'm going to bring on my minus 42 is equal to 3. Now, I'm going to go ahead and I'm going to combine my 42 and my 3, okay, by adding 42 to the other side. Now, 42 plus 3, that should give us about 45, right? So we got minus 8y minus 3z is equal to 45, okay? Now, we're going to go ahead and stop here because what we've done is we've combined both like terms, okay? The y's and the z's. And we've also isolated our number, okay? We want it to be in this format, okay? We want it to be both variables on one side with the number on the other. So remember that. 2 variables on one side, number on the other, okay? Now, tracing back our steps, you'll notice we left one of these alone, right? Because if I go to try to then plug my yellow piece into that second equation, you'll notice I don't have an x. But that's honestly what we wanted, because now, if you'll look, he's actually ready to go. He's already has a y and he already has a z ready to go. So we can actually use him and go ahead and jump right into our two variable system, okay? So let's go ahead and do that. So we have our 5y minus z is equal to negative 31. And then we also have our minus 8y minus 3z is equal to 45. There we go. Alrighty. Now what we're going to do with this is the same exact process we did just a second ago. We need to isolate a variable, and we need to choose one that has nicer numbers, and honestly that won't be as strenuous, okay? And I think, in my opinion, okay, we should go ahead and use this top one, okay? I think this top one will serve us better. So let's go ahead and solve for the z, okay? So let's do that. Okay, so I've got my 5y minus z is equal to negative 31, okay? So in order to solve for z, I need to go ahead and subtract 5y to the other side. Okay, so let's subtract 5y. These will go ahead and add to 0, and then I have minus z is equal to negative 31 minus 5y. Now, let's go ahead and get rid of the negative. The way we do that is we divide by a negative. You could also say multiply, okay? Both work just fine. And we have z is equal to 31 plus 5y. And everything's looking good. And that's what we wanted, okay? We want this, okay, to be isolated, okay? We want z to be by itself. So this is good. This is what we're looking for, okay? Now, we're going to take this green shaded part, and we're going to plug it into the other equation, okay? We're going to come in here and plug it into there, okay? And more specifically, we're going to plug it into where the z is, okay? So let's go ahead and do that. So I've got my minus 8y minus 3. Now, instead of putting z, I'm going to put 31 plus 5y. And this is all equal to 45. Alrighty. Now let's go ahead and do some more good old-fashioned mental math here. So I've got to distribute this negative 3, right? So negative 3 times 31, that's going to be a minus 93. And then a negative 3 times 5y, that's going to be a minus 15y. All right, things are going good so far. Now, we do have the ability to combine some like terms here, okay? And the like terms that I noticed right off the bat is honestly those y's. So let's go ahead and combine them. So I have negative 8 minus 15. That's going to give me minus 23y. And I've got my minus 93 is equal to 45. Now, looking at this right here, I need to add 93 to both sides. And that's going to give me, well, let's go ahead and do it. 93 plus 45. I got 138, so I've got, I'll go ahead and write it over here. Negative 23y is equal to 138. Now, all we have to do is divide, so we divide by negative 23 on both sides. And then we get 138 divided by that negative 23, and I get y equals negative 6, okay? And that's a big piece of information, okay? We've been looking for something like that. So, boom. That's one of our answers, okay? Now, what we're going to do is we're going to use this red piece, okay? And we're going to plug it into the green. Because if I plug it into the green, you'll notice it's set up so I can find the z value, okay? So let's go ahead and plug it in. So I've got, I'll go ahead and scoot down a little bit. I've got z. Oh, don't have my thing there. I've got z is equal to 31 plus 5 times negative 6. And that is going to be, well, it's going to be z equals 31 minus 30. That one isn't so bad. So z equals 1, okay? And once again, that's another big piece of information, okay? Now I have 2 red pieces of information, and that should allow me to go ahead and find my last remaining value, which is my x. Now guys, we used an equation back in the beginning. We used that gold one, right? That gold one is what we're going to use to go ahead and solve for x, because it's set up beautifully for us, okay? So what I'm going to go ahead and do is I'm going to plug in what I know. So I have my x is equal to negative 21 minus 3 times negative 6 minus 2 times my 1. Okay, and let's go ahead and zoom back in. Well, looking at this right here, I should end up with x is equal to negative 21 plus 18, because negative 3 times negative 6 is 18, minus 2. Now it's just a bunch of combining some like terms here, okay? So I've got, let me see here, 18 minus 21 minus 2, and I've got x, okay, is equal to negative 5. And that is my next red piece. Now with these 3 red pieces of information, we should be able to go ahead and create our coordinate point, okay? And that coordinate point is the intersection, okay? This is where all 3 of these graphs are going to meet up, okay? And the way we write it is we write x first, so we have a minus 5, comma, negative 6, comma, 1. Okay, z goes last. And that right there, ladies and gentlemen, that is our answer, and that is what we've been looking for, okay? This is an intersection point, okay? Now that's how we're going to use 3 variable substitution. So the main things to remember, okay, walking away from this is number 1, let me get my thing down. Number 1, isolate, okay? Make sure you isolate. And then 2, plug into both equations, okay? And then after you're done doing that, okay, you're going to repeat the process, okay? You're then going to isolate again, but with the 2 variable system, right? So number 3, step 3, you could say repeat. Okay, repeat process 1 and 2 with 2 variable system. So that right there, guys, is going to help you in doing this 3 variable substitution. This will take practice though, okay? These are very strenuous and long problems, and it's easy to make mistakes, okay, when we haven't had a lot of practice. So just understand that in time, this will come easier, okay? We just got to crank out a couple more, so when we do homeworks and stuff, make sure we're paying attention and using that time wisely to really focus and really just strengthen those skills as isolating and plugging into other equations, okay? Well, that's it for the video, guys. Thank you for listening, and if you need any questions, let me know. Ready? Bye.